Yeah, we're going to just show you a demo of the work that we've been doing on MBS user services today. But first, I'll just show a few slides. These are from a presentation I gave last February by the looks of it, but I've just selected a few to highlight in particular. So these are the 3GPP specs that we're implementing. So SA2 defined the multicast broadcast services in 23247. That's their stage 2 spec. And then SA4 has expanded that to further define the stage 2 specification of user services for MBS. And that's this MBS transport function and MBS function in particular. Then there's a stage 3 spec that SA4 has defined to go with that specifies all the protocols and formats to be used. Then there's a couple of CT specs that are relevant at the moment. The first one is this 29581, which is the API to configure the MBS transport function. That's mainly of interest here at the moment. And then there's this other 26561 spec that has some extra detail on protocol stacks, which I'll mention as I go along. So anyway, so let's just whiz through quickly. So first of all, we start off with the low-level SA2 architecture. And just as a reminder, this is a little bit of a simplification of what SA2 has specified. We've been working with the colleagues from the Polytechnic University of Valencia, and they've implemented these purple functions, the multicast broadcast service management function and the multicast broadcast user plane function. But they've done it in a slightly simplified way by extending the existing service management function and then the existing user plane function. So there's no actual reference point between these in the reference implementation they've done. But that's just a choice. It doesn't really affect what we're doing over here with the green stuff. So it's mainly the MBS transport function that we've been implementing. So it ingests content at this reference point NMB8, and then it spits out multicast packets at reference point NMB9 to the MBUPF, and then sends them downstream to the user equipment via this user plane function and the RAN. So if you're the sort of person that likes protocol stacks, this is what it looks like. So here's the MBS TF at reference point NMB9 talking to the MBUPF. And what this stack shows basically is that the multicast packets in this top layer need to be provided in a unicast tunnel, and that will become a bit more interesting when Dev shows his demo. But basically, one of the consequences of that is that because you're tunneling a multicast packet inside a unicast packet, you need to reduce the size of the packet to fit in one maximum transmission unit. So that's just an extra detail. So then we come to the next layer up, the SA4 user services layer for MBS. And here's the MBSF again in the control plane and the MBSTF in the data plane. But then we've got these additional functions that SA4 has defined. Well, in fact, one of them was SA3. So SA3 defines this MBS security function for exchanging decryption keys. In the case where your transmissions are encrypted, there's a SA4 defined application function for delivering user service announcements to the UE. And then there's an application server for unicast repair. And these interact with some functions that SA4 has defined in the UE side of things. So the MBSF client and the MBS transport function client over here. And then this has a media server that serves objects back to the application so they can be played back. So that's the user services architecture layer. And then the SA4 specs also define these things called distribution methods and operating modes. So there's a distribution method for objects and a distribution method for packets. It's the object distribution method that we've been implementing so far in the MBS transport function. And we've previously demoed this operating mode where you just send one file in and it transmits it once in the multicast flute session. But today we're going to be demoing this new thing where we've ingested a presentation manifest into the MBS transport function, and in this case a dash MPD, and then the MBS transport function follows the presentation that's defined in that dash MPD, and it fetches the media segments at the right time and puts them into the flute session to transmit them. So that's what we'll show in a minute. And this is a kind of a summary of how the MBS transport function works in this object distribution method. It ingests this is kind of rotated by 90 degrees compared with the diagram I showed before, but it ingests objects at reference point NMB8 from outside, and then it segments them, maybe applies some AL FEC to them, turns them into flute packets, and then schedules them for transmission down to the MB user plane function at reference point NMB9. And all of this is configured using a RESTful interface at reference point NMB2. And here again is a stack-oriented view. So there's two ways we can get it to operate. We can either get it to pull the objects using an HTTP GET from a web server, or we can push those objects into the MBS TF. And in the case of Dash, it's the MPD that gets pushed, but the objects described by the MPD are always pulled. And here's just an example of one of the configurations. In this case, the operating mode is the single shot and it's operating in pull, but we'll show a slightly fancier demo of the Dash operation today. So yeah, here's our reference implementation of the MBS transport function. So again, we pull or push ingest to the MBS TF here. So we have a class that looks after object ingest. The objects that are ingested get put into an in-memory cache called the object store. And all of this is under the control of this thing called a controller. And once they've been ingested, they get packaged by a packager. And actually, what that does is it uses libflute. This is one of the other reference tools that was contributed for LTE-based 5G broadcast, the MBMS system. And optionally, it has some ALFEC in there. And then once it's generated the flute ALC packets, it sends them down to the MB user plane function at NMB9. And again, this is all configured using this NMB2 reference point. So we have a RESTful server here that manages the configurations. And in a real system, these would come from an MBS function. Although in our demo, because we don't have one of these yet, Dev will show just a little command line posting of the configuration in. That's the class diagram that we have for this simple list operation. For Dash, it's not that much more complicated. We have an ingester, push or pull, we have an object store, and we have a packager. So it's a similar kind of pattern. I think that's pretty much it. Yeah. So I'll stop sharing. Well, unless there's any quick questions first. But otherwise, we'll go to the demo.
So I'm going to demonstrate the functionality of MBSTF provision with streaming object distribution operating mode. And this is so the MBSF provisions this distribution session to the MBSTF, and it has the following configuration. And if you recall Richard's slide, he was showing the network protocol stack, which had the MBUPF tunnel, and that the configuration for that is specified in the MBUPF tunnel address, which is the unicast address for to tunnel the packets to the UPF. And the user plane traffic flow info basically provides the multicast IP address to multicast the objects. And we have the object distribution data, which specifies the mode as the streaming and the acquisition mode to be pulled, and the media origin server to pull the MPD, which is specified in the ID's pull, which is shown here, and the object distribution base URL. So what happens is, as Richard described in his slides, so when the MBSTF receives this distribution session, it instantiates its internal components, such as the controller specific for streaming mode and a handler for the Dash manifest. It fetches the MPD from that demo media origin server calls the appropriate functions in a library that we have built to parse and manipulate MPDs, and to fetch the list of initialization and media segments, ingest these segments in the order of their fetch time, and transmits the fetch segments using RT-libflute as the serializer and transmitter. So here the RT-libflute library is configured to encapsulate the flute multicast packets. It generates in a unicast tunnel, which is specified over here, and prior to sending them to a socket. And for the demo, we will use the netcat as a receiver, and we will, meanwhile, we will run the Wireshark for analysis as well. So these are my demo systems. So we demo terminals. So we have the media demo media origin server on the top right, and MBSDF over here, and MBSF to send the distribution session. And we have a receiver, which is netcat listening to the tunnel address. And meanwhile, we are also running a Wireshark, as you see here at the host 127.0.7, which is the MB UPF tunnel address. And let's run the MBSDF now, and let's send the distribution session. And we can see that the packets are the objects are being received over here in the receiver. And let's see what's happening in the Wireshark. We could see the packets are being captured over here. Let's give it a bit of a time so that I think we have enough packets for our analysis. Let's stop it. Let's do a bit of a, let's give it a bit of a time. Okay. Yeah. Let's do a decode. So we had this port 5454, which is the IPv4 tunnel. Let's decode it up. Let's get into the inner multicast packet as well. So let's port and set it to now let me go to the first one. So we could see the TOI 0, which is basically the FTT, and let's see what is there in the FTT example. And in the file we have the TOI 1, which is to be the MPT that is to be fetched. And let's go to TOI 1 to see that the MPT is being. Yes, here we can see that the MPT is being fetched. And let's go to another TOI 0, which is the FTT, and let's see what we have. Sorry. Yes, FTT TOI 0, and this is the file with the TOI 2, which is basically one of the initialization segments, as you can see over here. And if we go to TOI 2, it basically fetches the initialization segments. And let's go to another TOI 0, which is the FTT, and we could see that that has a file with reference to TOI 10, which is basically the media segments. And if you go to the TOI 10, we could see the media segments being transmitted. So this is the demo that we demonstrate that the distribution session is being configured to the MBSDF from the MBSF, which then fetches the MPD and the appropriate initialization and the media segments. This concludes the demo for the day. Thank you.